Hello, hi. So in this video we'll be looking forward on how to do binary subtraction just like the previous video, like where we were doing binary addition. So in the previous video we saw that whenever you're doing binary addition, you have to look for the different possibilities or cases, right? Like the combinations of numbers that you'll be coming across. So in the binary addition we saw combination numbers as 0 0, 0 1, 1 0 and 1 1. Okay, similarly for binary subtraction also we'll be having similar cases and we'll see what is happening in each and every case. Alright. So in the case of binary subtraction, the different combination that we'll be seeing is basically 0 0, 1 0, 0 1 and then 1 1. Okay, four different possibilities. If I'm subtracting 0 minus 0, it is going to be 0. 1 minus 0 is yet again going to be 1. 0 minus 1, we'll see what is going to be, and then like 1 minus 1, it's going to be 0. So 0 minus 1, uh, so 1 is a greater number and 0 is a smaller number. So you're subtracting a greater value from a smaller number. Alright, so in this case alone, we'll be borrowing. My bad, just give me a second. So in this case, we'll be borrowing from the nearest largest value. Okay, so you'll understand that in a bit when we see some examples. So for simplicity's sake, let us just solve from simple examples and then iterate over the next set of examples. So we have, let's take an example of 1 double triple 0 1 0 1. Sorry, just give me another second. So we have 1 1 0 0 0. I think I have any problem, but does it have an impact? Alright, okay. Sorry. Alright, so we have 1 0 and then another 0, then 1 1 0 1 0 1. Alright, so in this case, let us subtract 1 0 0 0 1 0. Alright, so let this be the number. So as I told earlier, for example, let's say 223, okay. So let's take the example of 23. So 23, if I add a 0 before, right, it is still going to be 23. So just like that, if I add a number to the left side, if I add 0 to the left side of a number, it is not going to impact. But then 23, if I add a 0 to the right, it is going to impact because it's going to become 230. It's not going to be the same number. So I'm not adding a 0 to my left. Sorry, I'm not adding a 0 to my right, but I'm adding a 0 to my left, which is the same as the entire number. For example, 0 1 0 is the same as 1 0. Right? It's the exact same number, but I'm just adding a 0 to the left, so it's equivalent. So in this case, my number is going to be 10100. Alright, so this is going to be my number. So in order for me to subtract from the bigger value on my upper side, I'm just adding some 0 to the left so that I can make it like an equivalent size. Alright, so 1 minus 0, 1 minus 0, it is going to be 1. 0 minus 0 is going to be 0. 1 minus 1 is going to be 0. 0 minus 0 is going to be 0. And then 1 minus 1 is going to be 0. 1 minus 0 is going to be 1. 0, 0. And 1 minus 0 is going to be 1 yet again. So this is our value. So now let us consider the case where we have 0 minus 1. So for that, let's think of an example like 1 0 1 0 1 1 0. Alright. So this is our given number and we are trying to subtract from this the value, right? So 0 minus 0 is going to be 0, 1 minus 1 is going to be 0, 1 minus 0 is going to be 1, 0 minus 1. In this case, we borrow from the nearest largest value. The nearest value that you are seeing over here is 1. So I am borrowing from this value. So this becomes 0. When I borrow 1 from this value, this becomes 1 0. Got it? Now 1 0 is a decimal equivalent of 2. So 0 0 is represented as 0 in decimal. 0, 1 is represented as 1 in decimal, 1, 0 is represented as 2 in decimal, 1, 1 is represented as 3 in decimal. So 1, 0 is basically 2. So 2 minus 1 is going to be 1, right? So 1, 0 minus 1 is going to be 1. And then 0 minus 0 is going to be 0. 0 minus 0 is going to be 0. And then 1 minus 0 is going to be 1. Got it? So this is going to be the binary value when you subtract these two numbers. Alright. Let us consider another example where this borrowing is going to vary a little bit. So we have 1, 0, 1, 0, 0, 1, 0, 0, and then we have 1. Alright. So let us subtract 1, 0 from this entire number. Let me just change this up a bit. Okay. So 1, 0 is going to be 0. Oh, my bad. 1 minus 0 is going to be 1. 1 minus 0 is going to be 1. So 0 minus 1 is going to be, I cannot subtract. 1 is a greater value compared to 0. So I have to borrow from the nearest largest. So the nearest largest value that I am seeing after all the zeros is going to be 1 from this one. So this one is the nearest largest value, right? So from this value is where I borrow. From this I am borrowing to the next value that I am seeing. So this becomes 1, 0. Now I have to get it over here, right? So again from this I will be borrowing. So this is 2. Then if I subtract 1 from 2, this is going to become 1. So this value becomes 10. Sorry, this value now becomes 1, 0. Now from this yet again I am borrowing another value. Now this becomes 1 and this becomes 1, 0. So from 2 I am subtracting 1. From 1, 0 I am subtracting 1. This is going to be 1. Okay, 1 minus 1 is going to be 0. 1 minus 1 is yet again going to be 0. 0 minus 0 is going to be 0, 0, 0, 1. Got it? So I basically borrow from my nearest largest value and then I get it to my exact value. So when you're doing it, if you're having multiple zeros, so it's basically the first borrow is going to become 2. From 2 it will now become 1 and then again the next value is going to become 2 and then 1. So you should always write, whenever you're doing binary addition or subtraction, all the values should be written in binary. You cannot write the decimal equivalent of these values. For example, instead of 1, 0 you cannot write 2. Okay, got it? So we'll just see the examples once more. So given two numbers, you just have to do binary subtraction and you have to follow these simple rules. So 0 minus 0 is going to be 0, 1 minus 0 is going to be 1, 1 minus 1 is also going to be 0. Only in the case where 0 minus 1, I have to borrow from my nearest largest value. So in this case, we took the simplest example. 1 minus 0 became 1, 0 minus 0 became 0, 1 minus 1 became 0, 0 minus 0 became 0, and then 1 minus 1 also became 0. And then 1 minus 0 became 1, 0 minus 0 became 0, 0 minus 0 also became 0, and then 1 minus 0, we had 1 over here. Got it? Now in the next case, we saw all the remaining numbers are same, 0 minus, so these are the two numbers that we had. So 0 minus 0 we had 0, 1 minus 1 became 0, 1 minus 0 was also 1. The next number was basically 0 minus 1. So I cannot subtract, I didn't have enough. So I borrowed from my nearest largest value. Nearest largest was basically this one, the immediate left of it. So I borrowed 1 and then I got it over here. This value now became 1, 0. Okay, 1, 0 is basically a decimal equivalent of 2. So 2 minus 1 is what we did. So 1, 0 minus 1, nothing but 1. And then left is all same, 0 minus 0, which is 0, 0 minus 0 is 0, and then 1 minus 0 is also again 1. Okay, in this particular case, we had such a big number and then we had a lot of zeros. So let's just start from the left. Sorry, let's just start from the right. So 1 minus 0 is 1. And then we had 0 minus 1. I could not do. So I have to borrow from the nearest largest value, which was basically this value. So I took 1 from this value and I got it over here. This became 1, 0. But I wanted one value over here. So from this, I yet again borrowed another value. So from 2, I subtracted 1, which is basically became 1. And this value now became 1, 0. Again, I borrowed from this. This became 1 and I got my 1, 0 over here. So 2 minus 1 over here became 1. Then we had 1 minus 1, which is 0. 1 minus 1 was also again 0. And then 0 minus 0 is 0. 0, 0, 0, 0, 0, 0. And then 1 minus 0, we had 1. Got it? So hope it's clear. Alright. Thank you.